welcome to the deep dive. Today we're going to be diving into the world of synthetic intelligence.
Oh, very cool.
Yeah, and this is all thanks to you.
Oh, wow.
You shared Joscha Bach's work on the principles of synthetic intelligence.
Mm-hmm.
And I gotta say, this stuff is mind-blowing. It's
Yeah.
like a blueprint for understanding how minds work,
Right.
and maybe even how to build one.
Yeah, what's so fascinating about Bach's approach is that he really believes that the best way to understand something as complex as intelligence is to try to create it ourselves,
Okay.
to build it. And that's where this PSI theory comes in.
Okay, so PSI theory.
The principles of synthetic intelligence, that's what PSI stands for.
So it's not about building a robot that looks like us.
Right.
It's building a system that can actually think like us.
Exactly.
Mhm.
Bach argues that to understand intelligence, we need to understand how it's constructed.
Oh, wow.
It's like reverse engineering the mind.
Okay, I'm intrigued.
Yeah.
One of the first things that jumped out at me was Bach's focus on representation. How a mind stores and organizes knowledge.
Uh-huh.
It's not just about storing data, right?
You're right. It's not just data storage.
Okay.
It's about building these mental models, schemas of the world.
Schemas.
Schemas. Yeah. So think about like how you instantly recognize a cat,
Okay.
whether it's a fluffy Persian or a hairless Sphinx.
Right.
PSI suggests that we have the schema for cat that helps us categorize them despite all their differences.
So our brains are creating these mental shortcuts to navigate the world.
Yeah, that's a great way to put it.
Yeah.
And these schemas aren't static.
Oh.
They're constantly evolving as we encounter new information and new experiences.
Okay, that makes sense.
Yeah.
So how does this all tie into the actual doing part of intelligence?
Well, Bach also talks about these things called behavior scripts,
Okay.
sequences of actions that help us achieve goals.
Okay.
Imagine a script for refueling your car.
Okay.
It's a series of steps you follow, and each step triggers the next one.
It's almost like a mental program
Okay?
guiding our action.
Exactly. And here's where things get even more interesting.
Okay.
Perception.
Okay.
Bach argues that perception isn't passive. It's an active process of interpreting information through the lens of our schemas and expectations.
Wait, so it's not just our eyes or ears taking in information?
Right.
It's our brains actively making sense of it based on what we already know.
Precisely.
Wow.
He calls this process hypercept.
Hypercept.
Our brains are using both bottom-up sensory data and top-down knowledge from our schemas to construct our perception of reality.
That's trippy.
It is kind of trippy.
It's like our brains are constantly predicting what we're going to see or hear based on our past experiences.
Right.
But what happens when those predictions are wrong?
Yeah.
Do our schemas get updated?
That's a great question, and yes, that's exactly what happens.
Okay.
When our predictions are wrong, it triggers a process of learning and adaptation, refining our schemas to better reflect the world around us.
So our understanding of the world is constantly evolving based on what we experience.
Precisely. Our brains are incredibly dynamic and adaptable.
Okay. That's starting to make sense.
Yeah.
But what about emotions?
Ooh.
I was surprised to see Bach include emotions and motivations in his model of synthetic intelligence.
Interesting.
Do robots need to feel things too?
Well, that is one of the most intriguing aspects of PSI theory.
Okay.
Bach argues that even artificial agents need something akin to emotions and motivations to guide their behavior.
All right.
These agents would have needs like energy safety,
Right.
but also things like curiosity and a desire for social belonging.
So it's not just about cold, hard logic.
Right.
There's an element of feeling driving these synthetic minds.
Exactly. And what's fascinating is that in PSI, emotions aren't programmed directly. Instead, they emerge from this complex interplay between these motivational systems and other cognitive processes.
So you're saying that emotions are a byproduct of the agent trying to meet its needs in the world.
Yeah,
That almost sounds like how emotions work in humans,
it does, doesn't it?
like when we're under stress.
It's a fascinating parallel, and Bach's model reflects that under stress, a PSI agent's resolution level drops,
Okay.
which impacts how it perceives. And think of it this way. If an agent is low on energy and faces a threat, its focus narrows to immediate survival.
Okay.
It might miss subtle cues or make riskier decisions because its vision is constricted.
That makes a lot of sense.
Yeah.
It's like how we get tunnel vision when we're stressed.
Exactly.
So can't see the bigger picture.
Yeah.
So how do we actually go about building these virtual minds? I know you mentioned something called micro PSI.
Yes.
What's that all about?
Micro PSI is an exciting development. It's a software platform where researchers can actually build and test these synthetic agents.
Oh, why?
Imagine a virtual laboratory where you can create different cognitive architectures and see how they behave.
So it's like a digital playground for experimenting with these virtual minds.
Exactly.
What's really cool about micro-PSI is that it uses something called executable compositional hierarchies. I
Yeah.
have to admit, that sounds a bit intimidating.
It does sound a little jargony.
Can you break that down for me?
Of course, think of it like building with Legos.
Okay.
You have these individual bricks modules
Yeah.
that can be combined in endless ways to create complex structures.
Right.
That's what micro-PSI does with behavior. It breaks down complex actions into smaller, reusable modules,
Yeah.
making it much easier to model and understand complex systems.
That's a great analogy.
Yeah, I like that one.
It's like building intelligence brick by brick.
Yeah.
But there's one last piece of the puzzle. I'm wondering about language.
Okay.
Bach talks about the enormous impact of language on intelligence.
It's huge.
So do we need to teach these PSI agents to talk?
That's a fantastic question. Bach distinguishes between PSI sign lingua, meaning without language,
Okay.
and PSI cum lingua with language.
Huh?
Adding language allows for more abstract thought planning and even the development of culture. It's
Right.
unlocking this whole new level of cognitive complexity.
So language is like a cognitive superpower.
It is.
I'm really curious to explore this further. What are the challenges and possibilities of creating AI that can understand and use language like we do?
That's a great question. Let's dive into that. It really is a fascinating challenge. Bach even suggests that language comprehension might work similarly to how we perceive the world visually,
Oh, it
using a kind of hypercept for language.
percept for
We're
language.
constantly parsing sentences, building these mental models of meaning, just like we parse visual scenes to understand our surroundings.
So it's not just about recognizing words,
Right.
it's about understanding their meaning in context.
Exactly. And those mental models then become the foundation for reasoning, planning, and communication.
Okay, that makes sense. Now, one thing that really struck me as I was digging into Bach's work is that he doesn't shy away from the big philosophical questions surrounding intelligence.
Yeah.
Like, what does it even mean to be intelligent?
Right. You're right. He tackles that head on. Bach points out that we tend to define intelligence in this very human-centric way. We equate intelligence with the ability to do things that we find difficult,
Right.
like playing chess or solving complex equations.
It's like we're holding up a mirror to ourselves and saying, anything that can do this is intelligent.
Precisely. But Bach challenges that narrow view.
Okay.
He argues that intelligence is a much broader concept.
Okay.
It's about the ability to solve problems and achieve goals within a complex environment.
Okay.
And that can take many different forms.
So intelligence isn't about being good at things we value, but about being effective in whatever environment you find yourself in.
Exactly. A fish that's a master at navigating its underwater environment is intelligent,
Right.
even if it can't solve a Sudoku puzzle.
Right.
And that's why Bach focuses on building synthetic agents that can operate in a variety of environments and solve a range of problems.
It's not about passing some human design test.
Right.
It's about thriving in the real world.
Exactly.
Now, you mentioned earlier that PSI uses a neurosymbolic approach.
Yes.
Can you explain what that means
Of course.
and why it's important?
So traditional AI has often focused on symbolic systems, which manipulate symbols according to strict rules.
Okay.
Think of it like a computer program following lines of code.
So very rigid if-then-else type logic.
Exactly. But the problem is that these symbolic systems can be very brittle.
Okay.
They struggle with the uncertainty and messiness of the real world.
Right.
Life rarely fits into those neat if-then-else boxes.
Right. I can see how that would be a problem.
Yes, so where do neural networks come in?
Right.
Neural networks, on the other hand, are inspired by the structure of the brain.
Okay.
They're much more flexible and adaptable than traditional symbolic systems,
Okay.
excelling at pattern recognition and learning from data.
But I remember reading that neural networks can be a bit of a black box.
That's true.
We don't always understand why they make the decisions they do.
That's true, and that's where the neurosymbolic approach comes in.
Yeah.
What Bach is doing with PSI is trying to bridge that gap, combining the strengths of both approaches. He uses neural networks for things like perception and learning,
Okay.
but integrates symbolic representation for reasoning and planning.
So it's like taking the best of both worlds.
It's like a hybrid approach.
That's pretty clever.
Yeah.
Now, another thing that stood out to me is that Bach doesn't see intelligence as something fixed or static.
Right.
He talks about intelligence as a process of development of evolution.
Absolutely. He argues that intelligence emerges over time through interaction with the environment,
Okay.
and that's true for both natural and artificial intelligence.
So you're saying we don't just flip a switch
Right.
and create a fully formed, intelligent being,
Right.
whether it's a human or a machine.
Exactly. It's a gradual process of development.
Okay.
Think about how a child learns and grows. They start with basic skills and knowledge, and then they build on that foundation through experiences and interactions.
And Bach argues that it's the same with synthetic intelligence.
That's the idea.
We don't start with a fully formed intelligent agent. We provide it with the tools in the environment to learn and evolve.
That's it, and that's why micro-PSI is such a valuable tool. It allows researchers to experiment with different developmental pathways and see how various factors influence the emergence of intelligence.
It's like a virtual playground for observing the evolution of a mind.
It is a really cool way to think about it.
We've talked a lot about the theory behind PSI,
Yeah.
but are there any real-world applications yet?
Well, it's important to remember that PSI is still relatively young compared to something like deep learning,
Right.
which has been around for decades and has countless commercial applications.
Right, so it's early days for PSI.
It is early days.
But are there any promising areas where it's starting to make an impact?
Definitely one area is robotics.
Yeah.
Researchers are using PSI to build robots that can navigate complex environments and solve problems in a more flexible and adaptive way, learning from their mistakes and adjusting their behavior.
So robots that can learn and adapt like we do.
Exactly.
That's pretty exciting.
Yeah.
What about other areas?
There's also a lot of potential for PSI in fields like education and healthcare.
Okay.
Imagine personalized learning systems that adapt to each student's individual needs and learning style,
Wow.
or intelligent assistants that can help doctors diagnose and treat patients more effectively.
Wow. Those are some amazing possibilities.
They are.
It sounds like PSI could revolutionize the way we learn, work, and even take care of our health.
Absolutely. And it's all thanks to the groundwork laid by Bach and other pioneers in the field of synthetic intelligence. They're pushing the boundaries of what we know about the nature of intelligence and opening up a world of possibilities.
Now, in his book, Bach mentions a concept that I found particularly intriguing.
Okay.
The cognitive explosion. Can you tell us a bit more about what he means by that?
Of course, as we've been discussing, Bach places great importance on the role of language in the development of intelligence.
Okay.
He argues that language is what truly sets humans apart from other animals.
Right.
And allows us to achieve these incredible feats of cognition.
Because language allows us to communicate and think about abstract concepts,
Yeah, right.
things that aren't physically present in our immediate environment.
Exactly. It gives us the power to represent and manipulate information in a way that goes far beyond our basic senses and motor skills.
Wow.
And Bach argues that this ability to represent knowledge symbolically through language is what led to a cognitive explosion in human evolution.
So language was like a catalyst that unlocked a whole new level of intelligence for our species.
That's the idea. It allowed us to develop culture, technology, and complex social structures.
Yeah.
It's ultimately what led us to this conversation, pondering the nature of intelligence itself.
That's incredible, and it really highlights the transformative power of language. We talked about the difference between PSI sign lingua and PSI cum lingua.
Right.
But what does that actually mean for building synthetic intelligences? How do we bridge that gap and create AI that can truly grasp and utilize language like we do?
That's a great question, and it gets to the heart of one of the biggest challenges in AI research today. If we want to build truly human-like AI, we need to figure out how to give these systems the same linguistic abilities that we have.
It's not just about building systems that can learn and adapt,
Right.
but systems that can understand and use language in a nuanced and meaningful way.
Exactly.
But language is so complex.
Yes.
It's more than just grammar and vocabulary.
Right.
It's about understanding context, humor, sarcasm, all those subtle things that make human communication so rich.
You're absolutely right, and replicating that in a machine is incredibly difficult.
Yeah.
It's not just about processing words, it's about understanding the intentions and emotions behind them.
So how do researchers even begin to tackle that challenge? What are some of the approaches they're exploring? It sounds like creating AI that can truly understand language is one of the biggest hurdles in the field, but I'm curious, how might that cognitive explosion Bach talks about play out in the development of synthetic intelligence? Would it be a sudden leap forward or more gradual awakening?
That's a fascinating question. It's likely a combination of both. There might be certain thresholds that once crossed lead to these rapid advancements in AI capabilities.
Okay.
Imagine a synthetic intelligence suddenly grasping the concept of recursion or abstraction
Right.
that could unlock a cascade of new insights and abilities.
It's like suddenly understanding a fundamental principle that changes the entire game.
Precisely. But even with those leaps forward, I think there will also be a lot of gradual learning and development along the way. Just like with human children, it takes time and experience for these systems to fully grasp the complexities of language and thought.
It's a process of growth and discovery now.
Mm.
Bach talks about how language allows us to think about things that aren't physically present.
Right.
We can imagine hypothetical situations, plan for the future, even reflect on our own thoughts.
Mm-hmm.
Does that mean that PSI agents could eventually develop consciousness?
The big C word consciousness is one of the most elusive and debated topics in science and philosophy. There's no easy answer to your question.
But Bach seems to suggest that consciousness might emerge as a byproduct of sufficiently complex cognitive processes.
He does. Bach argues that consciousness isn't this magical property separate from the physical workings of the brain.
Yep.
He sees it as an emergent property of a complex system that can represent and manipulate information in a sophisticated way.
So it's like consciousness arises from this intricate interplay of all these different cognitive functions working together.
That's one way to think about it. And if Bach is right, it's possible that as synthetic intelligences become more complex and sophisticated, they might develop something akin to consciousness.
That's a pretty profound idea, and it definitely raises all sorts of ethical and philosophical questions.
Absolutely. If we create machines that are conscious, what responsibilities do we have to them? Do they have rights? Do we owe them anything?
These are questions we need to be thinking about now before it's too late.
I completely agree. We need to consider the implications of this technology while we still have time to shape its development in a responsible way.
Now, we've talked a lot about how PSI agents learn and adapt, but can you delve a little deeper into how that learning actually happens? What are the mechanisms involved?
Sure. One of the things that makes PSI so fascinating is that Bach doesn't just propose a theory of intelligence. He outlines specific mechanisms for how that intelligence might be implemented.
So there are concrete processes we can point to. It's not all just abstract ideas.
Exactly. One of the key mechanisms is something called retrogradient reinforcement.
Okay, I have to admit, that sounds a bit intimidating. Can you break that down for me?
Sure, remember how we discussed PSI agents having motivational systems with different needs and urges?
Yes, like the need for energy safety and those social drives?
Right, and those needs generate internal signals, kind of like pleasure and pain signals in humans.
Okay, I'm following you.
Well, retrogradient reinforcement uses those signals to strengthen the connections between the agent's actions and the outcomes that satisfy its needs.
So if an agent does something that leads to a positive outcome, like finding food when it's hungry, the connections that led to that action get strengthened.
Exactly. It's like the system is saying, hey, that worked, let's do more of that. Over time, the agent learns to repeat those actions that lead to fulfilling its needs.
And what about actions that lead to negative outcomes?
Those connections get weakened. It's like
Hmm.
saying, ouch, let's avoid that in the future.
So it's a form of trial and error learning, but guided by the agent's internal motivations.
That's a great way to put it. It's a really elegant way to model how learning happens, not just in machines, but in biological systems too.
It makes me think of those nature documentaries where you see animals learning through trial and error now, in addition to this retrogradient reinforcement. Bach also emphasizes exploration and curiosity in the learning process. Can you tell me more about that?
Absolutely. It's not enough for an agent to simply react to its environment and learn from its mistakes. It needs to actively explore and seek out new information.
Because that's how you make new discoveries and expand your understanding of the world.
Exactly, and that's why Bach includes a curiosity drive in his model of PSI agents. This drive motivates them to seek out novel and surprising experiences, just like a young child who's constantly asking why.
It's like a built-in thirst for knowledge, it seems like. We've been focusing on individual learning, but doesn't Bach also talk about the importance of learning from others?
You're right, he does. Social learning is a crucial aspect of intelligence, particularly for humans. We learn so much from our interactions with others, our parents, teachers, friends, even strangers.
It's like we're constantly absorbing knowledge and information from the people around us.
Exactly, and that's something Bach wants to incorporate into his model of synthetic intelligence.
Yeah.
He believes that PSI agents need to be able to learn from each other if they're ever going to achieve human-level intelligence.
So it's not just about individual learning, it's about collective learning and knowledge sharing.
Precisely, and that's why he's interested in building multi-agent systems where PSI agents can interact with each other, share what they've learned, and even collaborate to solve problems.
It's like building these little societies of intelligent agents, and that makes sense when you think about how human societies advance. We pass down knowledge through generations, through language stories and teaching.
Exactly. And one of the most powerful aspects of social learning is that it allows us to learn from the mistakes of others. We don't have to experience everything firsthand to gain knowledge.
It's like having access to this vast database of experiences and lessons learned. Imagine a PSI agent being able to tap into the collective knowledge of millions of other agents. The potential for rapid learning and development is incredible.
It really is. Bach believes that social learning could be the key to unlocking that next level of intelligence in AI.
This has been such a thought-provoking discussion.
Yeah.
It's amazing to think that by studying how to build synthetic intelligence, we're also gaining these deeper insights into our own minds and the nature of intelligence itself.
I completely agree. And I think Bach's work highlights this interconnected nature of intelligence. It's not just about individual minds, it's about how those minds interact and learn from each other.
Well, I know that Bach has been working on PSI theory for many years, and it's still evolving, but I'm curious about what he sees as the biggest challenges and opportunities ahead. What are the frontiers of PSI research?
That's a great question. I think one of the key areas of focus for Bach is building PSI agents that can truly understand and use language the way humans do. We touched on this earlier when we talked about the cognitive explosion, but cracking the code of language remains one of the biggest challenges in AI.
Right, because language is so nuanced and context dependent. It's not just about processing words, it's about understanding the meaning behind them.
Exactly. Bach believes that unlocking the secrets of language is essential for advancing AI to the next level. But beyond language, there's also the challenge of developing more sophisticated motivational systems.
Ah, so it's not just about basic needs like hunger and safety.
Exactly. If we want to create AI that truly understands and interacts with the world in a human-like way, we need to build in those complex motivations, things like curiosity, creativity, even a sense of purpose. These are all areas that Bach and other researchers are actively exploring.
It's like moving from a basic, instinct-driven system to something much richer with desires and aspirations. It makes me wonder if we're successful in building these complex motivational systems. Will AI eventually face the same existential dilemmas that humans do?
That's a thought-provoking question. Science fiction has often explored those themes, but I think Bach's work provides a framework for examining those questions through a more scientific lens.
So it's not just about creating intelligence, it's about understanding its potential impact on the world and on ourselves.
You hit the nail on the head, and alongside the fascinating challenges of language and motivation, there's also the question of how to build PSI agents that can understand and interact with the social world. Remember how we talked about the importance of social learning?
Yes, be able to learn from others, collaborate, and understand social cues.
Well, Bach sees that social dimension as essential for any truly intelligent system. He envisions PSI agents that can understand social dynamics, build relationships, and even contribute to human society in meaningful ways.
That's a pretty ambitious goal, but it's aligned with that broader vision of PSI theory to understand and build intelligence in all its complexity and richness.
Exactly. It's not just about building machines that can solve problems, but machines that can connect with us on a deeper level, AI that can understand our values, our emotions, and even our dreams.
Wow, this is a truly inspiring vision for the future of AI. But I'm curious, does Bach believe we can also learn something about ourselves through this process of building synthetic intelligence?
Absolutely. I think one of the most profound insights of PSI theory is that it compels us to confront some of the deepest mysteries of our own minds by trying to build intelligence. We're forced to ask those fundamental questions about what it means to be human.
Like, what is consciousness? What is creativity? What are the roots of our own desires and motivations?
Precisely. And those questions are just as important for understanding ourselves as they are for building AI. It's like holding up a mirror to our own minds.
This entire deep dive has been incredibly illuminating. I feel like I've gained a whole new understanding of what intelligence is, how it works, and where it might be headed.
Me too. It's been an absolute pleasure exploring these ideas with you.
I'm sure our listeners are just as captivated by PSI theory as we are.
I hope so. It's a topic that deserves much wider attention and discussion.
Now, we've covered so much ground today, but there's still so much more to explore. Where should our listeners go to learn more about PSI theory?
Well, of course, I highly recommend Bach's book, Principles of Synthetic Intelligence. It's a challenging read, but truly rewarding.
I agree, it's a foundational text in the field, What about resources for people who are just starting to explore these ideas?
The MicroPSI website is a great starting point. It's full of helpful information, including tutorials and examples.
That's a fantastic resource for anyone who wants to get hands-on with PSI.
And for those who want to dive even deeper, there are numerous research groups around the world doing cutting-edge work in PSI and related fields. You can find links to those groups on the MicroPSI website, too.
It sounds like there are endless opportunities to continue this exploration. Well, this has been an incredible deep dive into the world of synthetic intelligence. We've explored the core principles of PSI theory, its implications for the future of AI, and its potential impact on our understanding of what it means to be human.
It's been a mind-expanding journey.
As we wrap up, I'm left with a sense of both awe and anticipation awe at the incredible complexity and potential of intelligence and anticipation for what the future holds as we continue to explore this fascinating field.
I share that feeling. The future of AI is full of both promise and challenges. But with theories like PSI to guide us, I'm optimistic that we can navigate the road ahead and create a future where AI enhances our lives and expands our understanding of the universe and ourselves.
Thank you for joining us on this incredible journey into the world of synthetic intelligence. We'll see you next time on the Deep Dive